In this video we're going to look at the scope planning process. Um, there are four processes involved in scope planning, and the objective of those processes is to ensure that all of the work has been identified that needs to be done to produce the project deliverables. No more, no less. So you've identified all the work, and you've also identified exclusions, what's not included in the project. So it starts off with the plan scope management, and this is setting the rules for the next three processes. So that's what that scope management is all about. As I'll discuss later, we don't really use that one. Collect requirements. This is an important one. This is especially important with a consultancy project. For a construction project, these two are sort of irrelevant because the scope is already really well defined, so you don't have to define the scope as part of a construction project, because the scope is already well defined in the tender document and the contract document. So anyway, so we are talking about a consultancy project really for this one. So collect requirements is where you talk to the stakeholders, find out what their needs and requirements are. Now the main stakeholder is the client, so it's what does the client want, but also there may be people within the client's organization that you need to talk to. So for example, if you're dealing with Unitech and you're talking about, say, building a new engineering building, you'd be talking to the engineering department, the people that use the building. You'd be talking to the facilities management, who are the people that would maintain the building. You'd be talking to the accountants, the people that will pay for the building, as well as the Unitech project management team. So collect requirements can be within this client's organisation. You will also talk to people external to the client's organisation. So it may be neighbours. If you're doing a council job, you'll be talking to the community, so you'll be spending a lot of time doing workshops and things, bringing people up to speed with what it is and finding out what they want. Neighbours, you'll be talking to them as well. So not just the client, but also all the stakeholders. And what you're trying to do here is you're trying to get a really big picture of what the problem is that you need to solve before you jump into solving the problem. Before you start scoping out the project that's going to solve the problem, you need to have a really good idea of what the actual problem is. And so the next step after you've actually got a really good idea of what you need to address is you address it. You come in and you define the scope. You develop a detailed description of the product, what you're going to produce, and the project scope. And then finally, so you've got a really big picture, you've got a scope statement which says this is what we're going to produce, and then you've got it's a real big complicated picture. You need to break it down into smaller bits for you to be able to manage it. Most civil engineering projects are just too big to manage all by themselves. You need to break it down into small manageable pieces, which we call work packages, and we'll talk about that later. So those are the steps. We're going to look at them in a little bit more detail. So as I said, the plan scope management is you're supposed to produce this thing called a scope management plan, and on a big project you may well do that, but for most conventional civil engineering projects, the scope management processes, the identifying requirements, all those sort of things, are actually embedded in industry practice. So you go and work for an organisation, you'll be doing stuff and you'll stop and think, oh wait, I'm doing scope planning, okay? But so it's embedded in it. One of the things that would be included in the scope management plan, it's not just the planning, it's also how you're going to manage scope during the execution. So one of the things that might come up is what happens if during the execution of the project there are changes, there are scope changes. In other words, the client says, I want you to widen the footpath, or I want you to add another footpath, or could you please make the cycle lane a bit wider, or could you add another story to my building. All those things are scope changes. Now in civil engineering we call those variations, and if that happens during the execution, the construction of the work, it is what we call a variation. And NZS 3910 has this great big long section here describing what we're going to do. What is a variation? What is a variation, otherwise known as a scope change? What are we going to do about it? How do we incorporate it into our systems? and all of that stuff. So we don't need a special separate scope management plan for the project for those particular instances because it's already there. And that's just one example. There are other industry documents, and also within your organisation there'll be practices as well which sort of pretty well cover what this is. So we don't usually do a scope management plan for a conventional engineering project. Bigger ones, yes, probably do. Okay, collect requirements. This is important. This is defining the stakeholder needs and expectations. I've talked about this before. Developed incrementally, so you may have a few workshops with the people to educate them, to get their initial views, educate them a little bit more, and then they start sort of producing, you start getting feedback, and you gradually build on that. So you've got the project charter, which is the initial high level stuff that the clients developed. So it'll be, I want a 4-story high building, an office building, architecturally designed, all that sort of stuff. But it's not until you really sort of drill into the stakeholder details that you're actually getting a little bit more detail. Then you have meetings with the client, maybe meetings with the community if you are doing a council project. Meetings with suppliers, for example. What sort of materials are available. If you're doing a pump station, for example, what sort of pumps are available on the market and what can they do. Workshops, surveys, and what you come out of there is the stakeholder requirements. What do the stakeholders expect from this project? What does the client want you to do? What is the problem to be solved? And once you've got that, then you can start figuring out how you're going to solve it. Now, a lot of young engineers, they'll go straight into, oh, I've got the idea. They won't do that first bit there where they're really defining what the problem to be solved is, and therefore what you produce is going to be not as good because it's not going to address the real problem. So it's really important that you do this bit here. You do identify what the real problem is, and then you're able to apply expert judgment and come out with what's called a scope statement, which is a statement of what you're going to do. The detail of the project product and the associated component parts. This is what we're going to produce. It's also experience from previous projects. People have usually solved these problems before, faced them before and solved them. Sometimes you look at the solution, you think, oh, we could have done a little bit better. So that's what the lessons learned is all about. And what comes out of the whole process, as I said, is a scope statement, which is a description of the project product, and also the project scope as well. So the things that you'll have to do to enable that project product to be produced. So looking at it, the scope statement is the product scope description. So what's to be built? How do we know when the project's complete? What is the acceptance criteria? How do we know if each component's right? And right down to how do we know if we've got the right concrete? How do we know if we've got the right reinforcing steel? How do we know that the reinforcing steel is spaced properly? So that's where quality sort of comes in a big way. Deliverables, what needs to be produced, is probably the same. Exclusions, what's not included in the project. Constraints, time, budget, and assumptions that you've made. So the scope statement's really quite important because it is saying this is what we're going to produce. If you get the scope statement wrong, everything that you produce from there on is wrong. So let's see how that sort of works in a civil engineering scope, civil engineering type industry. Now this is for a DBB project, design bid build. So there's the consultancy agreement where the consultant is hired by the client to do the design. In that consultancy agreement, it defines the design project scope. And so it says, and the product scope as well, it says we want you to deliver a design in tender documents or something like that. So the output of this is not the road or the building or whatever it is you're doing, it is the documents that the design of it. So in other words, these are more like an outcome or a result, which is a design. Yeah, I guess they are sort of products in a way. They're a set of drawings of design. And so you go through these processes, concept design, preliminary design, detail design. And what this is, at the same time as doing the design project, you are going through the scope development, defining the scope for the construction project. So you're defining what this construction product's going to be. So this project, it has its deliverables are the detailed design and the tender documents, but at the same time its result is that it's developing the construction project product scope. And then you go to the then you go through the tendering project. So the tendering project you can regard as a different project as part of the bigger main project. And the outcome, you know, it doesn't have a product, it has an outcome, and that is the formation of a contract with a suitable contractor to do the building. So that's what the tendering thing's all about. So the deliverable for a tendering project is a result, which is a contract is formed. And so you've got the tender documents, which produce most of the detail about what the construction product's going to be. It might have been changed a little bit by the tender submission and by the tags in the tender submission or during the tendering period, and those go together to make the contract document. So that contract document is the construction product scope defined. It sets out exactly what is to be produced, the scope of the construction project. So you can see it's there's three projects sort of shown here. There's the design project, and the deliverables is the detailed design and the tender documents. The tendering project, which the result is a contract is formed with a suitable contractor, and the start of the construction project, which has its scope defined in the contract document. So you need to be really quite clear on how these all fit together, because that's sort of the basis of the civil engineering project management industry. So some of the things you need to consider, that was oversimplified, is you need to also consider consent and permit acquisition and management. So it doesn't, I didn't show it there, but as part of the consultant's project, they usually have to get the consents as well. And there'll be consent and permit conditions. So for example, there will be the conditions that you put in erosion and sediment control systems. So that needs to be added into the scope of the construction project. There might be monitoring that's required to be undertaken, and that will be added into it as well. Contract conditions and requirements, so the construction project, there will be conditions that the contractor has to get insurances and bonds. Now that is additional, that is part of the scope. Agreements with stakeholders, there might be some cross agreements that you're going to maybe oftentimes if you're digging up someone's driveway to put in a pipeline, you'll reinstate it, so that needs to be included in the whole thing. Value engineering constructability, oftentimes you'll look at the future proofing it, for example, or how can we provide value for the whole thing. For example, with the State Highway 18 project, they were building a motorway, and it was a sort of 10-kilometre long motorway, and in the future there was going to be a road going over top of the motorway, and so there's going to be a bridge built over the top of the motorway in the future. So what they did when they were building the motorway, they put a pier in for this new bridge. So you drive along the motorway, and there's just a pier sticking up between the between the north and south lanes. And it's there for when that bridge goes over. So it was good thinking. It was thinking in the future we're going to have to build this bridge. It's going to be a real pain trying to build a pier right in the middle of the motorway when it's operational, so we'll build it now. So once again that gets added to the scope. Establishment and temporary works, so establishment is establishing your access road, your site facilities, pillar columns, all that sort of stuff. And temporary works, things like scaffolding, sheet piling, all those sort of things. You need to consider those because they are also part of the scope. They're not part of the final product, but they are required to enable the final product to be built. And interfaces between projects, so that's also something quite important. Now in PMBOK there's a whole lot of complicated words, you know, product scope description, acceptance criteria, and all that sort of stuff. But the fact is they're just talking, there's different words for things that we know are in a construction contract. So the product scope description and the deliverables, what they're talking about there is that product that is defined in the specifications and the drawings of the contract document. Now most of that is in the tender document. So the tender document has the specifications and drawings. It may be modified a little bit during the pre-tender communications, but generally most of it is defined in that specifications and drawings. In fact, that's what they're there for, to tell the contractor what he's supposed to build. Acceptance criteria. There'll be testing sections in the specifications. So for example, when you look at the concrete specification, it will have requirements for testing the concrete when it comes on site. Do a slump test, and that the supplier should provide some certification of the compression tests. Okay, and it'll define those. It'll tell you, it'll refer to a standard which talks you through exactly how that's supposed to happen, and it will also say what acceptance is not is what the acceptance criteria is. If you have a slump of 50 millimeters, that's acceptable. If it's a slump of 100 millimeters, not acceptable. So that's what the specification does, as well as talk about the standards of workmanship and materials. It talks about how you test it and what acceptable limits are for those tests. Exclusions, the preliminary and general section right at the start of the specifications will talk about what's included in the project and talk about what's not included, so that exclusions. In the conditions of contract, I think it's section 10 of NZS 3910, talks about time for completion, and that tells you what your time constraint is. Your budget constraint will be the tender price that was sent out in the contractor's submission. And quality, as I mentioned before, is in the specifications. So one more concept related to all this is project interfaces. The PMBOK call it a battery limit, I'm not sure why. So an interface is the boundary where sub-project responsibilities meet, and you need to allow for this in the scope of the project. So for example, this is a pump station, and it shows 4 projects being undertaken to build this pump station. So you've got the civil works people coming in and constructing the slab, digging a hole and putting in the wet well, which is shown in orange. The electrical people, which put in the switchboard and the power cables to the pumps. Mechanical people, which supply the pumps and the rising main, and the pipe work to the rising main. And then there'll probably be someone sort of building a big rising main, sort of 2-3 kilometers up to the next pump station. So you've got 4 projects there, and each one of those projects has to have an interface defined. So for example, the civil project needs to have bolts in the right places for the switchboard to connect into. So you need to allow in your scope for them to put the bolts in the right place. Likewise, they would need to build a plinth which the pumps are going to be mounted on. The plinth has to be the right size, the bolt connections need to be in the right place, so that needs to be defined, and it is part of the scope. The power, the connection between the power and the pump, that needs to be defined. So it's quite important that you define those interfaces and you include what is required in the scope of the project. And the last of those steps in the scope is, so we've defined the whole big picture, but it's too complicated for us to comprehend or manage. And so we go to the work breakdown structure. We take that big bridge or that big motorway and we break it down into smaller bits. So we break the bridge down into the piles, the piers, the towers, the deck, the suspension cables, the abutments, the anchorages, all those sort of things. You break them down into smaller bits. Usually structured by the deliverables, but you'd have other things in there like establishment, temporary works, and those sort of things. And by doing that, by defining it into smaller packages, work packages, it makes it easier to define the whole project, easier to manage the project, and easier to monitor it. Now we're going to talk about this more in the next video, and it's a very important thing for you to understand.